All right, guys, we're going to go ahead and get started. My name is Dan Abebayehu. I'm not a professor. I'm a postdoctoral fellow here in the department, but I want to welcome you all to BME2104, Cell and Molecular Biology for Engineers. I am a fifth-year postdoc, and I took this class about 13 years ago, and so I'm pretty excited to be here with you all and to go through this course with you. We have the benefit of having a team of TAs that are going to help with this course. We have a graduate TA named Taylor and 3 undergraduate TAs, John, Catherine, and Eddie. If you guys are here, can you raise your hands? We got 2 of our TAs here. So if you guys need any help, Eddie and John will be among the people on the team that will be available to help you. So to go through the course objectives for this course, for today, it's going to be largely an introduction to the course, what the semester is going to be like, what are the expectations for you all, as well as the expectations that you guys should have of us as we go through the course this semester. The first course objective is to be focusing on acquiring the basic knowledge and central concepts for key cell biological processes. One of the first things I want to draw your attention to are that some of the words are in blue. Throughout this semester, we're going to be having key terms or key concepts that are going to be highlighted that we really want to try and draw your attention to, because there's going to be a lot of things that we're going to be discussing, but there are definitely some key things that we want you guys to focus in on that will be important for you in this class as well as for future courses. And so when we talk about the basic knowledge and central concepts, we're going to be talking about a lot of the key concepts, a lot of the key ideas and theories that underlie cell and molecular biology that will serve as a foundation for future courses that you guys are going to be in. We're going to be identifying how these fundamental cellular and molecular biology processes tie to human disease. So everything that we're going to be discussing in this class is going to be against the backdrop of some sort of human disease, and we'll be also using that to better understand how do the current clinical therapies use molecular biology to try and address this disease. And as I mentioned, I took this course 13 years ago. A lot of the slides and a lot of the things have not changed, but what I'm going to be trying to do over the course of the semester is updating some of the material, because in 13 years, a lot has happened in cell biology as well as medicine. We're going to be learning to combine concepts from different contexts to address complex biological problems. This is one of the first courses that you guys are going to have. You may have already taken some courses in the fall semester, forgive me, that started to do this, but for some of you, this might be the first class where in the BME curriculum, you're going to be tying together a lot of things from chemistry, biology, physics, calculus, all coming together. And this is going to be one of the first courses that really does that for you. And so we're going to be moving from memorization to complex synthesis, as well as tying different concepts together. And we're also going to be trying to use new knowledge to critique and evaluate the current clinical therapies and propose alternative approaches. So as I mentioned, we're going to be looking at what the current clinical therapies are for some of the human diseases that we'll be looking at. But also you guys are going to be having projects where you're going to be trying to propose a new therapy. You know, the idea is we're trying to equip you all with the knowledge and the know-how to try and think of what might be a better solution than what's currently clinically available. Because you'd be surprised, a lot of BME students have done a great job of proposing new ideas in BME design discovery or in their capstone that then becomes licensed and a new company is found around it. So I understand the idea of I'm not equipped to propose a new idea. That's what we do in this curriculum. We're trying to come up with new ideas and tying together different concepts for creative solutions. And finally, we're going to be trying to communicate complex ideas in multiple different ways, but in an accessible way to a broad audience. The projects that we're going to be having, we'll be discussing them later on today, but we're going to have projects that focus on different modes of communication and trying to take complex things and being able to distill them down to their key ideas in a digestible way for anyone, whether they're a fourth-year BME student or a high school student, to be able to understand and appreciate. So for the accessibility in this course, for my accessibility for you all, I'll be available 15 minutes before and after each class. The idea is that if you guys have any questions about this course, the material, the projects, or anything, I'll be available before and after class to try and chat and help answer any questions that you all might have. I'll also have dedicated office hours or student hours available. So as I said, I was in this curriculum, and I can say honestly, I never did a really good job of going to office hours, just because I sometimes would either think I can figure it out on my own, or I don't want to bother the professor in this course. You know, office hours is a bad term. Student hours is probably a better way to try and define it. These are times in our day that we want to try and be available to you all to answer any questions, however simple the question might be or confusing the question might be. We're here to help you, and I'll be available on Wednesdays and Fridays from 3 to 4 p.m. Wednesdays, I'll be in MR6. That's the adjoining building that way. Sorry, I was confused. MR6, if you go through the double doors across the hall, MR6 is through the next set of double doors, and I'll be upstairs in the conference room every Wednesday from 3 to 4. And I'll also be in my office every Friday from 3 to 4, MR5 1229. So if the times before and after this class or those office hours don't work for you, please send me an email, and I'd be more than happy to meet with you all. I'd be happy to discuss material in this class or outside of this class. Some of you might be fourth or third years and trying to figure out how do you, how ought one to think about NSF fellowships or what to do after graduation. I'm happy to discuss any of that, to be honest with you. So I'm available for that. I'm not great by phone, and I'm not great with spontaneous visits. There might be times where I'm under a deadline trying to finish something, and I will not be as accessible as I would like to with a spontaneous visit. So I would highly encourage you all to reach out to me if you want to try and set up a one-on-one visit to talk through the material or anything outside of the class. So for our TAs, we already have some dedicated times for their availability to try and discuss either materials or the projects, and to be available to you all. We're still finalizing some of our schedules, but we're going to try and make sure that once it's all set up, we'll make that clear to you all and have it on the very front of the class collab page. And one key thing with accessibility to this course is that you need to be able to use the doors for using your UVA Health ID. If you don't have one, the folks at the BME office can help set that up for you. So things to do before each class. One of the important things to do is to view a pre-lecture video that we have that'll be posted on Colab. Some of them have already been posted up. There are links to YouTube. For this semester, we're going to be using previous year's pre-lecture videos, and these are only 30-minute pre-lecture videos. So it'll be primarily, I think, for the first half of this course where there are going to be pre-lecture videos, whereas the second half, there won't be, I think, pre-lectures. I'll need to double check that. But these pre-lecture videos are only 30 minutes long. And what they're intended to do is to help try and get us all on the same page with key things. So for example, the first lecture that we're going to have on Tuesday is on amino acids. And so some of you all might have already taken biochemistry. Some of you all maybe did really well in chemistry. Some of you all might not have. And what we're trying to do is to get everyone on the same page to make sure that we're set up for what the lecture covers and how we apply it to specific diseases. And also importantly is that you will be held accountable for the material on the pre-lecture videos, because again, they establish a common foundation for what we're discussing during the lectures. Next, if desired, and we'll talk a little bit more about what that means, to prepare, you need to prepare for an in-class 10-minute quiz. These quizzes will be done electronically on this link, and I'll make sure to have that available each time. But what these quizzes will look like is you'll be using either a laptop, a tablet, or your smartphone, and you need to make sure that they're charged. I didn't get a chance to walk through, but I don't know how many chargers or outlets are available for where you all are sitting. So that just means before you come to class, please make sure that whatever electronic device you're going to be using, that it's sufficiently charged. These quizzes will consist of just 7 multiple choice questions or some free answer questions. So these quizzes are not designed to take very long. but rather just to try and help get everyone to try and provide an assessment of how we're doing throughout the course of the semester. And these quizzes will be graded immediately, and following the quiz, we'll have a quick Q&A for 5 to 10 minutes discussing any quiz questions that might have been unclear or why certain answers are the way they are. And later today, we'll be taking a quick mock quiz. I understand first day of class hearing quiz is a little scary. It's honestly just to get you familiar with the website and to what it looks like to navigate through it and what that and to get us all on the same page. Okay, so quizzes versus exams versus both. So if you remember when I mentioned the quizzes, I said if desired. So for this course, you have the option to take either a weekly quiz or a quarterly exam, or you can take both. And what I mean by that is quizzes will cover just 1 week of material, and the exams will cover 1/4 of material. So on both the syllabus and on the CoLab homepage, where we have a bit of a calendar layout for the entire course, you'll see that it's kind of broken up into different quarters. And so you'll have an exam for each quarter. You can take one or either, or you can take both. And if you take both, whichever one you did better on is the one that will define your quarter, your grade for that quarter. And so we're trying to split these up into quarters just to give you a sense of how you're doing throughout the course of the semester. And again, you can take both if you'd like, or if you feel like you'll do one better on one or the other, you can do that. And you can switch it up. 1 quarter you can do quizzes, next quarter you can do exams, the next quarter you can do both. But the sense is just to try and get you all as much opportunities to engage with the material, to get used to it, and to engage with it as much as possible. So there are no makeups. If you feel like you're going to miss something, if something comes up, if someone gets COVID, please reach out to me. I want to work with you all, and I want to be as accessible as possible and to try and be as accommodating as possible. But oftentimes with this course, it's really hard to give makeups. So we can set up alternative testing situations if need be, or to reschedule things, but makeups are not going to happen. And there will be no givebacks. What that means is we don't want to get into an arguing match about certain questions, because what's going to end up happening is with a class of this size, different people will start arguing for different questions, and then the entire quiz becomes an argument. And the nice thing about this course is that these questions that we have for the quizzes and the exams have been used over the course of many years and have been vetted and tested and have worked. So we're not going to be doing givebacks for quizzes and exams. The exams will be about 4 to 5 times in length. So what that means is the exams will either be 28 to 35 questions long typically. And I'll make sure to come out with a printout to help you navigate the quiz questions or the exam questions on a printout, as opposed to trying to navigate it on your phone or a computer. And if you know you're going to miss, again, please alert us ahead of time. If you have to go into quarantine or something comes up, I think all of us can appreciate over the last 2 years that everyone's personal lives are all over the place right now. And so things happen. I got in a car crash yesterday. And so things happen. If something like that happened, please let me know. And we want to be as accommodating, as accessible to you guys, okay? And so, yeah, I'll just leave it there. So the questions in this class have sometimes been labeled as tricky or confusing at times. The main reason for that is because typically, so this is typically a second-year class. In your first year, a lot of the material that you've gone through and a lot of the material that you've studied is oftentimes usually regurgitation, where you're memorizing things and you're trying to spit back out what you've memorized. This class is trying to teach you and to encourage you to shift and think a little bit more differently. So according to a verbal illustration, and I encourage you all to participate with me. And yeah, so what we're all going to do is we're all going to say pots 12 times quickly, all right? Pots, 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 pots. What do you do to green light? You go. Exactly. So again, regurgitation is not, or like memorization is not going to work. You need to think about what the question is actually asking you. So in the past, people have tried to use flashcards. People have tried to use different ways of doing memorization. But one of the best ways that the curriculum throughout the entire BME curriculum that really helps, this might sound silly, is talking about things with your peers. Talking things out in a 3 to 4 person study group, talking it out on Piazza, talking it out with the TAs, being able to put things in your own words, articulate questions in your own way, and to think about things from a different angle or perspective. It's important for you to think about with each quiz or exam question that you come across. It's important to think about what the intention of each question is. What is it asking you? What's the question? This is an incredibly important skill, not just for quiz and exam taking, but whenever you guys will enter into research, or specifically even for your capstone, as you're doing experiments, it's important to think to yourself, what is the question here? What are we trying to accomplish? What are we trying to answer? What are we not trying to answer? And so the questions that we'll have will sometimes be recall, but also be critical thinking. What's there, what's not there, how do we apply this? So your projects for the semester. The first project you'll have is a graphical abstract. So we'll have forgive me, I should have said this earlier. The exams and quizzes will cover 60% of your grade. The projects here will cover 30% of your grade. And the projects are broken up into 3 parts. We have the graphical abstract, we have the 3-minute thesis video, and a 2-page research statement. For all of these projects, what you're going to be asked to do early on is to identify a disease or a biological problem of interest to you. And once you've identified that, we'll ask you to try and think about what is a hypothesis that you want to try and work on and workshop throughout the course of the semester. Now, what's going to be the case in this class is also true in real science. Sometimes our hypothesis changes. Sometimes what we originally think actually isn't quite true, and we need to try and shift it a little bit. And that happened last year when we first implemented this new project design. And I think that's actually a great way to try and reflect what happens in science, that you have one idea that you come up with, and as you engage with the primary literature, you realize, okay, either this has been answered or this has been rebutted, so I need to shift or try and refine this a little bit more. And so over the course of the semester, you'll be working on a specific hypothesis that is represented by each of these projects here. You'll be using primary references to develop that testable hypothesis. And what I mean by primary references, it's important to note here, is that these are actual research articles that people have published. A great resource to find these is PubMed. Another one is Google Scholar. And so you want to make sure that you're not looking at review articles, which is usually just people trying to get a sense of what is the current state, what is the landscape of this specific area of science. These are not experiments that these people have done. So we want to encourage you to look at actual experiments that people have done. What are they reported, and what have they shown? And these will be kind of the backbone to help inform your hypothesis that you're going to come up with for these projects. This might be obvious, but it's worth noting. These have to be related to cellular molecular biology. I had a few students last year that tried to pivot and go in a completely different direction. But it's important to know that the reason why we're doing this is a way for you to come up with something that really interests you, that could either be something related personally to you or something that you're really fascinated by. And it needs to be related to cellular molecular biology, but we'll also, if it's loosely related, we might help pivot a little bit to try and focus in on how can this be related to the material we're going through this course, and to help equip you to develop really compelling projects. Now, it's important to know that it might be a little intimidating to see 3 projects that we're going to be working on throughout the course of the semester. These projects are going to be interrelated. What that means is that they're going to be kind of woven together in some ways and rely on one another, but they're also independent. So you are doing 3 different things. But if you, for example, the graphical abstract is what we're going to be doing first. If you really put your work into a great, compelling abstract, that's going to make your 3-minute thesis video a little bit easier. That's going to make your research statement a little bit easier for peer review as well as final review, and to make it a little bit more compelling. And this is trying to illustrate how these things are woven together. And if you put the work in on the front end, the rest of the semester is going to be a lot easier to work on, because I think you'll have a project that you're invested in and you'll want to see do well. So the first submissions for each of these projects will not be graded. We'll be just be checking for completion, but they'll also be peer reviewed. So what we're going to be doing is we're going to be having each of you set up in groups of 5 based on whatever your research topic is, and you'll be giving feedback to one another on their abstracts, on their 3-minute thesis video, and on the research statement. And then for the final product, the grades for that will be assigned by the teaching team. So a huge part of scientific research is peer review. We read we review each other's papers, each other's screen applications, and we help give feedback. And it's important to be able to give that good feedback. And we're going to talk a little bit more about that later. So for this graphical abstract, and if you have any questions, please feel free to raise your hand and ask anything. For this graphical abstract, what you'll be asked to do is craft an illustration that describes the problem, the hypothesis, or your proposed therapy. And you'll be allowed to use any software that allows you to do this well. If any of you have experience with Adobe Illustrator, that's great. It's a fantastic software that can be really hard to use, but if you can use it well, and importantly, if you have access to it because it's expensive, you're free to use it. However, I will be providing access to a new resource that's called BioRender. It's a great new, very user-friendly online software that allows you, that's specifically geared towards medicine and biomedical research. And so what you'll be able to do, you'll be able to pull over and drag a cell membrane, pull over and drag cells, different tissues, a mouse, DNA, RNA, whatever. And it really helps you create really compelling images in a really easy, user-friendly way. And I'll provide the login information on the COLAB site. You'll be expected to incorporate this graphical abstract into your other projects. So again, your 3-minute thesis video, you'll be using this graphical abstract and pointing to it and referencing it as you're trying to describe the problem, your hypothesis, and the therapy. The grading on this will be based on completing your first and final drafts, the scientific accuracy, and this will be, and the scientific accuracy will, you'll get feedback on that from your peer review as well as from the final product from the teaching team. Your creativity as well as your clarity. So there's some templates that they have on on BioRender. We'll be able to know if you use a template, just drag and drop and try to submit that. It's usually quite clear. I've had students do that in the past, and it's usually easy to identify. What we're trying to do is encourage you to be creative and think of new ways to try and illustrate whatever it is you're identifying for your project. The 3-minute thesis. So this is a really new and great tool that people have been using lately that's meant to try and help you distill your project in 3 minutes and try and articulate it in a really compelling, succinct way. And so you'll be making a 3-minute video presentation that communicates the background, why this is important, the significance of it, what your hypothesis is, what you're going to do, and what the anticipated outcomes and the implications of what this could have. Being able to communicate those things is incredibly important, and being able to do that will serve you well throughout the rest of your time here at UVA, because I think in BME, you may already be realizing how important it is to be able to write well and speak well in terms of giving presentations. And so this is meant to help equip you with those skills now. What you're going to be doing is you're going to be submitting this as a pre-recorded presentation video form. You can use PowerPoint presentation, but also I've realized that Zoom is a great tool for this. You can create a little video where you can create a video where you're sharing your PowerPoint slide or your graphical abstract, and you just have yourself in the top corner speaking and being able to reference your abstract and make a really easy 3-minute video that way. Prior to your final submission, again, you will receive feedback. Again, you're going to be getting peer review from the people in your group, and we will also vote on top videos. I was hoping to try and line it up with March Madness and call it like a March Madness 3-minute competition. We'll see if that works out. But our top videos will get extra credit at the end of the semester for it. Finally, your 2-page research statement. It's going to be a research statement that describes the study that you want to do to test your hypothesis. The grading criteria for this is really similar to how grants are reviewed for both NSF and NIH. We're going to be looking at the significance, the innovation, the approach, and the broader impacts. Again, we want to try and help you develop the skills to write really compelling research statements and grant applications. And so the great thing about this is that this format, it's only 2 pages, but it's going to match what the NSF Graduate Research Fellowship is. That is one of the most sought after research fellowships for people who go to grad school. It gives you a lot of money for your stipend. And if you can get that, it kind of springboards you to be able to get other fellowships that are even more prestigious. And so in addition to that, it'll also meet the format for the Harrison Undergraduate Award that you can use for, I think you have to, I don't know if you have to be a fourth year, but it's something, these are skills and this is a format and this is an idea that you can take with you and use potentially for these fellowships. We had one student last year that got the NSF. And so this is meant to try and equip you with the skills to be successful. You'll be evaluated on the completed portions of it throughout the semester. You'll be asked to write an abstract at one point. You'll be asked to write the methods section. And then towards the very end of the semester, we'll ask you to piece all of this together and weave it together for a first draft that you'll then again get feedback from your peer review group. And then at the very end of the semester, you'll submit the final product. So the peer reviews. Why do we do the peer review process? An altruistic purpose of the peer review process is to make the scientific work of others better. We want to try and help each other. We want to try and lift everyone up and make everyone's work a little bit better and to serve our community. I've had the benefit of just now getting into the peer review process of helping to review papers for journals and helping to review grant applications. And it's great to see the really interesting work that people are doing and to help make it better by refining it. And there's also, to be honest, there's also a selfish purpose. It sharpens my own thinking. Seeing how other people write, seeing how they present their ideas, it makes me go back to my own work and helps refine my own work. It helps me see the most cutting edge work. Seeing what people are putting in their grant applications, I'm able to take that back and think of how I can apply some of these ideas to my own work and make my own work better. And it also helps you gain some clout. If you get the reputation of becoming a great reviewer, you get the opportunity to become a member of an editorial staff. You know, I use some of the professors in this department who are great reviewers, like Dr. Kevin Janes. He's on Science Signaling's editorial board because he's a great reviewer and it gives you clout. So what good peer reviews look like? They are unambiguous. They are very clear and they get to the point. They don't have lengthy, confusing language. It cuts right to the point. They're also incisive and insightful. They get right to the crux of the matter. And they also provide the really relevant feedback that authors might not have considered. And finally, they're both general and specific. They both talk about the big picture of whatever it is you're trying to propose, as well as the very specific experiments that are talked about and how they might be missing something or how they might not have considered some sort of underlying assumption that is important to that experiment. Okay, so that covers a lot of the administrative stuff throughout the course of the semester. What are we actually going to cover? So in the cell and molecular biology course, we'll be discussing a lot of the different categories of biomolecules. We'll be talking about lipids, proteins, nucleic acids, RNA and DNA, and as well as some carbohydrates. And we'll be tying them together to look at the critical fundamental processes in cell and molecular biology. We'll be discussing memory transport, how things diffuse across and are transported across the membrane. We'll be looking at how DNA replication occurs. We'll be looking at how DNA is transcribed and how the precursors for protein are taken from DNA transcription and translated into actual proteins. And we'll be looking at metabolism and how the energetics that are needed for all these processes are provided through different facets of metabolism. And at the end of the semester, you'll be able to look at a video like this and be able to describe exactly what's happening. We'll also be looking at cellular immunology. This is near and dear to my heart. I did my PhD in a molecular immunology lab. And so we'll discuss innate immunity, adaptive immunity, and being able to see how these things are meant to operate and what they look like when they recognize the self as foreign or do not respond to the appropriate things that are foreign that shouldn't be in our bodies. And as I mentioned earlier, we're going to be discussing all of these things in the context of human disease and the clinical applications. We'll be looking at a variety of diseases and trying to understand at the cellular and molecular level what is happening, what's going wrong, and what are the clinical applications to try and make it right, and how potentially your project ideas might be able to make those clinical applications even better. We'll be looking at rare diseases like listeriosis, as well as even more common diseases like diabetes. And we're going to try and seek to identify the applications most closely connected and associated with cell molecular biology. So these diseases that we have are vetted and tested to try and make sure that they fit as closely as possible to the topics we're going to be discussing in this class. So one of the things that's really unique about BME is that you're going to be getting a lot of different professors who you're going to have close contact with, either through the courses, through Ideas Lab, and through Capstone. And up to this point, at least I can remember my first year, these large lecture rooms where there's a professor at the front, they just seem like some weird professor who's not a person, and it's hard to relate to them. And so in BME, you're going to get to know all your professors, and I wanted to provide a little background about myself. So like I mentioned, I did my undergrad here in BME at UVA. I took this class 13 years ago. It was taught by Will Guilford back then. And it's funny, I can remember as I went through the lectures, as I was preparing for this class, I can remember like, oh yeah, I remember that. I don't remember that. I definitely remember that. And so I can identify with a lot of you in terms of what's going on during your second, third, and fourth years. And so again, I'd be happy to talk about any of that. I did a lot of research as an undergrad in tissue engineering and biomaterials. And the way I got plugged into research was as a first year, just applying to BME. There was a fourth year guy that I met in BME who's graduating, and he said his research was on angiogenesis. And I just nodded my head. I'm like, oh, angiogenesis, yes, it's very important. I had no idea what it was. But as soon as I looked it up, it was this idea that new blood vessels emerging from existing ones to meet some sort of demand, and this idea of the growth of new tissue that's like a normal part of our body. It sounded amazing. It sounded like science fiction. Like there's a lot of things in BME that sound crazy, but this simple process of angiogenesis, to me, it sounded incredible, and I wanted to learn more about it. And so that's how I got plugged into research right away as an undergrad. And from there, I went to go get my PhD at VCU in BME. And my research was focused on trying to figure out how we could take scaffolds that are meant to promote tissue regeneration and angiogenesis, and how we could change the immune response to them simply by changing the architecture or the stuff that's in there. And so this was a project that I really enjoyed, and it helped give me a background in fundamental molecular immunology, as well as tying it together with tissue regeneration. And I didn't realize it at the time, but the field of immunoengineering was taking off. And so I've kind of hopped on board, and that's kind of where I've been now. And now I'm doing my postdoc here at BME, back at UVA, looking at immunostromal axes. Basically, that's a crosstalk of immune cells to fibroblasts and cells that make scar tissue or new tissue, and what that looks like in lung fibrosis or in biomaterials. And again, as I said, it seems like sometimes professors have no life outside of work, or sometimes seem like they just sit down and listen to NPR all day and read presidential biographies. So I'm here to dispel that myth. So my family, my wife and I met here at UVA. A week after we graduated, we got married, moved to Richmond, and started a family. Right now we have 4 boys. The oldest is 6.5, then a 5-year-old, and a 2.5-year-old, and a 6-month-old right now. And I think we're done. And so we have a really loud and violent house, but it's a fun house. We live in Richmond. We have a great community of family and friends from our time living in Richmond, and we realized we don't want to leave that. And so, especially when we're raising 4 young boys. And so I live in Richmond. I commute from there every day, and yeah, and I love it. It's gives me a lot of quiet time in a loud house. So outside of work, I am a sports junkie, for lack of a better phrase. I love to play sports, watch sports, talk about sports, do it all the time, love it. Especially UVA basketball. April 2019 was probably one of the happiest moments of my life. Outside of my marriage and outside of my kids, it was incredible. I love music. I love playing it, listening to it. I enjoy reading good books. And for all of these things here, this is a great exercise that Will Guilford did. he described how, okay, these are the things I like to do. You probably have an assumption of what professors do for each of these things. They love to play squash, they love to listen to soft jazz and alt rock, and they love to read presidential biographies. For me, I love to play any sports, but basketball and soccer are my true loves. For music, my entire life I've been listening to rap and R&B, and I think it's the best thing out there. And for books, I love sci-fi and fantasy and good fiction. It's one of the things that reading good fiction, I think, is really important for scientists, because for all the work that we're doing, we're trying to tell a good story. We're trying to tell a compelling story about our work. And even though BME is a very hard curriculum and a very hard major, the ability to tell a good story is really important. And so whether it's a good fiction in terms of a book or short stories, I highly recommend it. I think it was Francis Collins that said, we need scientists to read poetry and we need poets to read science. And I think that's really important. And finally, my life outside of work, I have a great community of family and friends that we spend a lot of our time with, and we raise our kids together. And we just bought a bunch of land that we're just gonna have our kids camp out on and live and have a lot of fun together out there. So what was I doing as a second year? I know that there's also not second years in this class, but because it's 200 level class, I'm assuming that I picked second year because it's largely a second year class. But as a second year, for extracurricular activities, I was really privileged to coach a basketball team at a local private school. It was, in my mind, I thought the coolest job ever that you could have as a college student, because it was really flexible. It didn't pay a ton, but it was super fun and I loved it. I was a photographer on the side for the Cab Daily and for other stuff. I still love photography. I sometimes think that if I didn't do BME, I would have wanted to major in photography, but I'm really glad I didn't do that. And as a second year, like I mentioned earlier, I got my first real stint in a lab. Edward Bochwe was a professor here. He went to Georgia Tech, and now he's at University of Minnesota. But he was the one that got me plugged into research. And he was the one that said okay to me as like a brainy second year, saying, I want to do stuff and your stuff seems cool. And that the message there is, if you can demonstrate enthusiasm and to be able to talk intelligently about a professor's work, they're going to want you in their lab. For lack of a better phrase, the sooner that we can get people in the lab and the sooner we can get them on board and develop skills, all of a sudden, you guys will be equipped to have your own projects and answer really cool questions. And so for me, I was able to do that. And because of Dr. Bochwe's encouragement, he was the one that said to me, like, I think you're good at this. I think you should go to grad school. Because at the time, I didn't think I can go to grad school. Like, those people that get PhDs are like crazy and really into this stuff to a degree that I'm not. And he said, no, like, you should do this. And so I think getting plugged into research early, I think, can help you realize perhaps things that you're excited about that you don't know yet. And I'd encourage you to do I'd encourage all of that for you. So things to do in this class. One of the things I want you guys to think about as we're going through this material is to remember and to reflect on the evolutionary pressures and constraints on the topics we cover. What that means is we want you all to think about why are things this way? What are the pressures? What are the constraints on the system that made translation this way, that made transcription this way? And there's a great quote that says, nothing in biology makes sense except in the light of evolution. So as we're going through the material in this course, just remember to think about why is the system this way? As I mentioned earlier, I want you all to ask questions. Throughout this course, I will pause and take a break, perhaps take a sip of coffee, perhaps take a sip of water, but I want to give you all the opportunity to jump in and ask a question, because everyone benefits from the questions that you're asking. There might be another person in the room that has the same question but is nervous to ask it. Just ask the question. I encourage it, and I want that all for you. And there's also the potential benefit that the more you ask questions, that if you're someone who asks it's not about the right questions, but if you're someone who's constantly engaging and asking questions and trying to make sense of things, even if your question is, help me make sense of this, if you're someone who constantly does that, that could help your final grade in this course. And it's also something that reflects well in terms of if you need a recommendation for something, if you're someone who comes to office hours, asks questions, gets engaged in the course, this goes beyond this course. If you're someone who does that, you can ask, getting a recommendation letter is really easy when you do that. And so I encourage you to all ask questions. All of the lectures in this class will be posted as a video online on our Colab page. And so avoid the urge to just write down word for word everything that's said in this course. That's what YouTube is for. You can go back and rewatch the lecture if something didn't make sense. What I encourage you all to do here is to try and listen and to try and comprehend what we're discussing, comprehend the processes, why are they the way they are? And if something doesn't make sense, that's your opportunity to ask a question. So please don't write down word for word what's going on. Rather try and listen, understand, and engage. So things to do outside of this class. If you have any questions, please attend office hours. That'll also be a resource for you all as we try and work through the projects we have in this course. Focus on practicing the vocabulary more than memorizing it. And so, as I mentioned earlier, having some sort of study group or having a group of people that you feel comfortable not to look like a fool in front of, to try and use the words that we're using in this course so that you can have it in your own comprehension, in your own words, in your own understanding to help make sense of it a little bit more. And we'll also have the Piazza discussion board available for you guys to pose questions that the teaching team can help answer to. And so by mid-February, the expectation is we're going to be working on our projects continuously throughout the semester. Now, this does not mean that all of your free time should be spent on these projects, but rather we're going to have chunks of the projects that we're working on that we're going to have deadlines throughout the semester to help keep you on track. Because a lot of times when there's just a project with a deadline, speaking from experience, the work is done the week of the deadline. And so this is to help provide you a track to keep you on board, as well as an opportunity to give you feedback continuously throughout the semester so that you all are getting a sense of, am I on the right track? Is this the right idea? Has this already been done? So before our next class, we'll have taken a survey. So I'm going to go ahead and make that survey live now.